So let's go with some examples of how to implement the power rule and some of the basic antiderivative that we showed last time. Let's go here to the board, and let me start with the other set. Alrighty. So first, notice that this is a power. So if we're going to do antiderivative of that power, we can write in this way. We can use the property of the constant and take out the constant of the antiderivative, and we're left with x squared dx. Now we can use the general formula of the power. Remember that is antiderivative of x to the p is x to the p plus 1 over p plus 1 plus c. And so if we use this formula, we get that this is 3 times x to the 3 over 3 plus c. Or, notice the 3's cancel, we get x cubed plus c. Now, this second antiderivative is very familiar, right? You can remember that the derivative with respect to x of tangent to the minus 1 of x is 1 over x squared plus 1. So when you find this and you need to do the antiderivative, there's not a lot that you need to do. When you say, you set up the antiderivative like this and you say, oh, okay, so this is tangent to the minus 1 of x plus c. And that's it. You don't need to do anything more in this scenario. If you have constants or things multiplying, then you make sure to take those out, but that's what's going to happen here. Similarly, in the case of sine, since we know that the derivative of cosine of x is minus sine of x, then we can say, oh, okay, so the antiderivative of sine of t dt, notice that this is the variable of integration, then it gotta be cosine, but because we don't have the minus in here, we're gonna have to put the minus in here. So minus cosine of t plus c. Now, in the last scenario, we have a constant, but that constant can be interpreted in two different ways. Well, yeah, first you can just take out the constant and leave it as the integral of 1 dx, and you can think as the integral of 1 as being x. So this is going to be phi x and then plus c, because that's at the end what we're going to get. But the other way that you can think of this is, well, if we have phi times 1 dx, you can think of this as 5x to the 0. And then in this way, you can see it as a power. And this is 5x to the 0 plus 1 over 0 plus 1 plus c. And this is just 5x plus c. Okay? Any of those two works. Now let's move on to the second sets of the derivatives. In here, we're going to use much more complicated functions, and we're going to use mostly the property for the sum of the antiderivatives. Notice that this is a lot of function that we can split in different antiderivatives, and some of them requires a little bit of algebra. So for example, here we have a product, but we don't have integration for product, or we don't have antiderivative for product. So what we do is we multiply and then solve. So let's take a look at that. Now, in this first scenario, I can rewrite all this and split into different parts. I can write this as 3x to the 5 plus 2, and let's not forget the dx, 1 dx minus 5 square root of x, but square root of x can be seen as x to the 1/2 dx. So notice that now we have only powers that we can use. So this is 3, and this is x to the 6 over 6 plus 2x minus 5, and this is x to the 1/2 plus 1. So that's going to be 3/2. So it's 3/2 over 3/2, and then plus c. If you want, then you can simplify here. You're going to get x to the 6 over 2 plus 2x, and finally this is going to be minus 10 over 3, x to the 3/2 plus c. And that is how we solve the first integral. For the second integral, we're going to have to do a little bit more of work. Notice that this can be rearranged as a different power. Notice we can first divide this as 4x to the 19 over x squared minus 5x to the minus 8 over x squared. So it's important to make that algebra first to simplify the powers. So that can be rewritten as 4x to the 17 here. Remember, this is how powers work. If you have this power over this power, just subtract the exponent. Now this is the x minus 5 times, and now if you're subtracting here, we're going to get x to the minus 10 dx. And so now we can integrate. This is 4x to the 18 over 18 for my antiderivative, minus 5x to the minus 9 over minus 9 plus c. Remember, this is minus 10 plus 1, so minus 9. And that's the result for this particular example. This will be the antiderivative of this function. Notice the little trick here is splitting the denominator so we can simplify the powers. Now for the next example, what we want to do is we want to multiply. We don't have, again, product rule for antiderivative, so we need to just rearrange this whole integral. This is going to be 2c cubed minus 5c squared, and then now plus 2c minus 5. So that's the whole rearrangement of this. I don't have similar terms, so I don't have to add anything before integrating. And now I can just split this in different antiderivatives and 4 antiderivatives if you want to. But if you have the ability and you can see it right away, you can just do it in the spot. So for example, this is 2c to the 4 over 4 minus 5c cubed over 3 plus 2c squared over 2 minus 5c plus c. So if you have the ability, if you can see it very clearly and don't have any issues with that, you can very much do it on the spot and just find the antiderivative of each of the pieces and then add them. Similarly here, derivative of 2x, this is twice the derivative of x squared over 2 and plus 3 times, and the derivative of the antiderivative of cosine is minus sine, so minus sine of x plus c. So if you remember your rules, you can very quickly use them and use them without having to do it step by step. Okay, this is the end of part 2 of antiderivatives. In part 3, we're going to take a look at applications.